So we're going to do this example that's taken from the book, and we're given this value of secant, which is minus 17 over 8, and we're told that theta is between 0 and pi, so between 0 and 180 degrees. So that means what? That means we're here, right? So we're either in the first or second quadrant. Find the values of the other 5 trig functions. Okay, so I'm going to show you 2 solutions. Solution 1 is not the one I actually do myself, but this is what they show in the book. So you can decide which of the 2 solutions you prefer. So the idea is that the trig functions, right, whether it's tangent, cotangent, secant, cosecant, they're all related to sine and cosine. So the first thing you want to do is try to find what sine and cosine are equal to. So secant will give you access to cosine, because secant is 1 over cosine. So secant of theta being 1 over cosine, that tells you that cosine is 1 over secant. And then I just replace secant by minus 17 over 8. Flip everything around, and bingo. Okay, very, very quickly I found the value of cosine. After that, in the book, they're going to use a Pythagorean identity to find the value of sine. So they use the main one, which is cos squared plus sine squared equals 1. So knowing what sine squared, cos of theta is, okay, cos squared is going to be minus 8 over 17 squared plus sine squared, and that's going to be equal to 1. So solving for sine squared gives us 1 minus. Now minus 8 squared over minus 8 over 17 squared, that's 64 over. So you have to be careful here, right? Minus 8 over 17 squared. This is 8 squared over 17 squared. Okay, but then as we send it on the other side, there's this minus that comes in. Okay, so this minus is not due to this minus sign here. It's actually due to the fact that we're sending the entire term on the other side. So minus 64 over 289. So what is that? That's 289 minus 64 over 289. And let's see if they're nice. 289 minus 64, and yes they are, it's 225. That's another perfect square, so we're going to end up with a nice rational number, and no square roots essentially. So sine is going to be plus or minus, right, the square root of 225 over 289, which is plus or minus 15 over 17. Now we have to decide, is it plus or minus? Okay. Now remember, we have to decide in which quadrant we're in. We're in the first or the second one. But whether we're in the first or the second quadrant, sine is positive. We can actually decide if we're in the first or the second. Look at your cosine. Cosine was negative. So cosine is negative when you're in the second quadrant. And no matter where you are in the first or the second, sine is positive. But we know we're in the second, so here we know that sine is positive and cosine is negative. So we're going to add this just to justify. Sine of theta is positive in quadrant 2. My best bracket. Okay. So positive, so that means I'm going to just replace those by positive signs. So 15 over 17. Okay, and once we've got sine and cosine, okay, everything else is easy. So sine over cosine, how do you calculate that? Well, you don't calculate, you just replace by the values we found before. We get minus 8 over 17. Like this, so as you simplify, you're going to get minus 15 over 8. There's another way of getting tangent, because since you have secant from the start, there's a connection between secant and tangent using a trig identity. So it's possible to use, or you could use the fact that 1 plus tan squared is secant squared, okay? So you can use that to solve for tangent, okay? But I find it easier once you have sine and cosine just to replace by those values. After that, okay, with secant we have it already. Cosecant is 1 over sine. Now sine is, what is it again? 15 over 17. So you flip that around, you get 17 over 15. Okay, and what are we missing? We're missing cotangent, which is 1 over tangent. So you just flip tangent around, so minus 8 over 15. Okay. So finally, if I summarize, we've got all 6 trig functions for that angle. Now, this, like I said, this is not my the solution I prefer. So my preferred solution. So I'm going to ignore the negative sign of secant. So you'll see why. So ignore the negative sign first if there's one. Okay. So I'm essentially going to look at the absolute value of secant. So absolute value of secant is 17 over 8. Okay. Which means that I don't like to work with secant. I prefer to work with cosine. Secant is 1 over cosine. So the absolute value of cosine is 8 over 17. And I'm going to look at that as the cosine of something. Okay. So cosine is what? It's opposite over, no, it's cosine is adjacent over hypotenuse. So with this in hand, I'm going to construct a triangle, a right triangle, which shows this feature. So I'm going to put theta here, although it's not exactly theta. But like I said, I'm essentially ignoring the negative signs first. So adjacent over hypotenuse. So let's say this is, I can think of this as either 8 over 17 divided by 1. So on my adjacent side could be this, and this for my hypotenuse. But it's actually nicer to work with a triangle with integer sides. So I'm going to magnify everything by 17. Or in other words, if you prefer, I'm going to look at the 8 as the value of my adjacent side and 17 as the value of my hypotenuse. Okay? So this is basically the same thing as magnify by a factor of 17, the previous triangle. So I get two similar triangles. Okay, so the trig functions are ratios of sides, so those ratios are going to remain the same no matter which triangle I look at. But it's just easier to look at the second one because now I'm working with integers instead of working with fractions. So obviously, first thing I want to do is calculate this opposite side. And how do I calculate this opposite side? I'm going to use the Pythagorean theorem. So now, 17 squared is 8 squared plus O squared. So the opposite side squared. So the opposite side squared is 17 squared minus 8 squared. So that's 289 minus 64. And that's 225. So that makes the opposite side equal to 50. Okay, and now I've got a triangle. I've got all 3 sides, and it's super easy. I've got, if I look at sine of theta, well, sine is what? It's opposite over hypotenuse. Cosine is adjacent over hypotenuse, and this is where I'm going to adjust those values. Okay, so in we said we're in the second quadrant. In quadrant 2, sine is positive, but cosine is negative. In the so in quadrant 2, can't write anymore. Quadrant 2, sine is positive, and cosine is negative. So cosine is going to be minus that. Okay, so I've got sine, I've got cosine, and then look at tangent, super easy to get. It's opposite over adjacent. Okay, and finally for cosecant, I just do it's the reciprocal of sine, so 17 over 15. Secant, of course, we're told what it was actually, so I'm just going to recopy it here. And finally, cotangent is 8 over 15. I made a small mistake. I also have to, in the second quadrant, sine over cos, so sine is negative, it's positive, cosine is positive, right? Cosine is negative, but also have to keep in mind tangent. Tangent is sine over cosine, so it's a positive over a negative, so it's going to be negative, so this should be negative here, and negative there. So you see I have very, very quickly all 6 trig functions just by working with a right triangle whose sides have integer values. And this is really what I prefer. I prefer that than the previous solution where you have fractions to work with. So I prefer not to work with fractions if I can, because I tend to make mistakes. So we're going to do another example like this in the last video.